With the release of 3ds Max 7, we've also updated the internal mental ray implementation to the latest version of the mental ray renderer, and with that we've included the subsurface scattering shaders. So here you can see on a model created by David King of Siggy, what we're going to do is just do a couple quick tests with subsurface scattering. So in this case I'm opening up the material editor. There we go. And now in the material editor what we're going to do is set up a standard material on this guy. So go in here and I can pick from subsurface scattering fast material, fast skin material with displace, or a physical material. In this case I want fast skin, so we'll just throw that in there. If you wanted to use the physical material, you can use that for things like realistic phenomena, like the way light passes through liquids like milk in a glass, or the way they pass through blocks of objects like cheese. Things where light softly diffuses through them. Candle wax is another example. So in this case we're doing skin specific. So the first thing I want to do is set up what the overall shader looks like. So we're just going to take the defaults in this case, drag it and drop it, and hit render. And you can see it'll kick through it quite quickly. Now in this case, it's probably got a bit of a waxy look to it just because not a lot of settings have been set up for scale and various other things. But you can see that the light is bleeding through the thin areas of the model very nicely. We're getting some nice diffusion around the surface as well. Now in this case, to simply set it up, the first thing you want to do is control the overall diffuse coloration. So this is what you would traditionally think of as the bitmap you normally put on the surface. So to do this, I'm just going to go to my original Max version of the material, pick on it and say copy, then go back over to overall coloration and say paste. This is a new little handy feature added to the material editor where we can copy and paste from all the slots, copies or instances. It's a very handy way to move things around. So in this case we've now got a material on it. But the thing to pay attention to is the underlying settings. Here you'll notice that we have first the epidermal layer. This is the top layer of skin, so this is the color that's built into that top layer. And then beneath that you have settings for the scatter weight and scatter radius. This basically defines the thickness of that layer and how much light gets diffused around inside of it. Beneath that we have the subdermal layer, that's that fatty layer just underneath that, and it also has the same controls for thickness and scatter. And then underneath that is your back surface. This would be your veins, arteries, things like that that you want to have picked up in the rendering. Underneath all of those, of course, you have controls for overall specular control, reflection edges. We also have advanced options. One of the big problems with using something like subsurface scattering is it's heavily dependent on the scale of a model. If the model is off from a normal world scale, then it's very hard to get the numbers right. So what you can actually do is go in and adjust for a global conversion factor. So if your model is way too big, well then you can scale up your conversion factor to match that, and all the settings that we have above in this area will then adjust based on that scale factor. So it's a very handy way to go in and just sync up your material to a model that wasn't originally designed to real-world units. So with all that set up, let's just go and quickly take a look at what this would look like with a fully done render. So in here we have a version of Siggy. This is actually a version done with Max's scanline, straightforward, specular, bump maps, and diffuse maps. Not a lot to it, no subsurface scattering. Now if we go back, we can pick up Siggy with subsurface scattering. And in this case now you're seeing a lot more diffusion through the ear. You're seeing a much softer lighting going on. It's actually a much more appealing image because of the subsurface scattering. You can obviously fake this with many different methodologies with a scanline render, but it's often so much easier just to go in and put subsurface scattering on in Mental Ray. And then of course, just to give you the full idea, if all you had was the light in the back, this is what subsurface scattering is doing with that light right now. This is how it's actually moving it through. So it just gives you an idea of what subsurface scattering is actually tackling in these images.